Hello students, so today we will be looking into the numericals of first chapter of class 9 physics, that is measurement and experimentation. As you know, this chapter involves a lot of conversion from one unit to another, especially based on mass and length. And we have different units of length like light year, angstrom, and all these will be used up over here. So a lot of learning is required on your part to remember the conversion units. So we'll be seeing one by one all these sums which are there. We will be starting with the first exercise of this measurement and experimentation. So let us take a look at question number 1. It says that the wavelength of light of a particular color is 5800 angstrom, and we have to express it in terms of nanometer and meter. So we know that the relationship between angstrom and nanometer has to be known. So first of all, I am writing that 1 nanometer is equal to 10 angstrom. Okay, and about meter part also I should know is this: 1 angstrom is equals to 10 to the power minus 10 meter. So you will require these two conversions for these two part. So we look at the A part, where we have to bring it in terms of nanometer. So I am writing that given wavelength which is there, so that is given to us as 5800 angstrom. So if I have to convert to nanometer, 1 nanometer is 10 angstrom. So 1 angstrom will be 1 by 10 nanometer. That is why we go to divide it and we get it as 580, that is nanometer. So nm. Now for the B part, wavelength is now 5800 angstrom. So as you see here, to convert angstrom into nanometer, you need into meter, you have to multiply with 10 to the power minus 10. Because it is in 10 to the power, okay, so we need to write it in scientific notation, where the decimal has to be always between the first two digit. So here the decimal is over here, so I need to bring it 3 places back. So we need to write it then 5.8 into 10 to the power 3 and then 10 to the power minus 10. So 5.8 written, bases are same, they are multiplied, so the powers will get added and you will get it as 3 minus 10 as minus 7 meter. So this is your answer for the B part and this was the answer for the A part. So just the conversion values, remember them. It is very easy to do this numerical. Now let us take a look at number 2 numerical, which says the size of a bacteria is 1 mu. 1 mu stands for micro, which is 10 to the power minus 6. And because it is the size of what it told, so it will be 10 to the power minus 6 meter. Find the number of bacteria in 1 meter length. So if there is 1 meter length of bacteria, what is the number of bacteria? So we'll first write here, that is 1 mu is equals to 10 to the power minus 6 meter. So we will write here number of bacteria in, that is 1 mu, that is becoming as 10 to the power minus 6 meter, that is equals to 1. So now number of bacteria in 1 meter, because we are finding for 1, you know, we will have to divide this one with this number 10 to the power minus 6 here. So 10 to the power minus 6, so that gives me 10 to the power 6 as the number of bacteria present in 1 meter of it. So now let us move to this third numerical, which says the distance of a galaxy from the Earth is 5.6 into 10 to the power 25 meter. So that is the distance given to you. Assuming the speed of light to be 3 into 10 to the power 8 meter per second, find the time taken by light to travel this distance. So you are given the distance, you are given the speed, so time formula has to be used, which you all know, that time is equals to distance by speed. So distance given here is 5.6 into 10 to the power 25 and the speed is the speed of light 3 into 10 to the power 8. So let us divide this 5.6 with 3. So you know that 3 ones are 3 will go, 2 will be left, 26. 3 eights are 24, so 2 is left. 3 6 are 18, so it will keep on going 6 6 6, and 10 to the power it will become 25 minus 8. So it becomes 1 point. I can round it off up to the second place, 1.87 into 10 to the power 17. We are finding the time, so this is in second. This finishes a very simple sum based on the formula time equals to distance by speed. Now to a very easy sum in question number 4. The wavelength of light is 589 nanometer. What is its wavelength in angstrom? So as we have done a previous sum based on this conversion, you know that 1 nanometer is 10 angstrom. And we have to convert here nanometer only into angstrom. So I will write here wavelength is given to us as 589 nanometer. So it will become 589 into 10 angstrom. So it becomes 5890 angstrom. So a very direct and a simple numerical is finally done. Let's see what this question number 5 tells us. It says the distance of the nearest star Proxima Centauri from the earth is 4 into 10 to the power 13 kilometer. Express it in light year. So it means now this distance is given in kilometer. We have to get it in terms of light year. It means I should know the conversion between that 1 light year in terms of kilometer, what is the distance. So I will write that first. That value has to be remembered. So 1 light year is equals to 9.46 into 10 to the power 12 kilometer. So this is what is going to be used now. So distance is given to us in kilometer as 4 into 10 to the power 13 kilometer is given to us. This is given in kilometer. If I have to convert into light year, 1 light year is 9.46 into 10 to the power 12 kilometer. So if I have to convert this into light year, I need to divide by this. So I will write here 4 into 10 to the power 13 divided by 9.46 into 10 to the power 12. Okay, now this is in light year. So 10 to the power 13, 10 to the power 12, I cancel this. I am left with over there 10. It means it is 40. If I remove the decimal year 946, then I need to write 100 here. So you get a long division to be done, a big number to be reduced. But if you go on to divide it and check it, you are going to get it as 4.26, and this much light year you get it. So that finishes question number 5. So again another sum where it was just based on conversion. So now let us come to question number 6, which says it takes 8 minutes for light to reach from the sun to the earth's surface. If the speed of light is to be taken as 3 into 10 to the power 8 meter per second, find the distance from the sun to the earth in terms of kilometer. So we are asked to find the distance, time and the speed is given to us. So we will use the formula here. Distance is equal to speed into time. So here the speed is 3 into 10 to the power 8. It is in meter per second. Time is given as 8 minutes. So should be converted to 60. Okay, to be multiplied by 60 to convert it into seconds. And since the distance is asked in kilometer, this will be getting in terms of meter. So what I do is I divide it here by 1000. Okay, so here if I multiply 3 into 6 is 18. 18 into 8 will give me 144, and then this 0 into 10 to the power 8 divided by 1000. So this will cancel 1 0 because of 100. Here decimal will move 2 places backward. So I will get 1.44 into 10 to the power 8 kilometer. So this is the distance from the sun to the earth's surface. Done. Now coming to the last numerical of this exercise 1A, it says the distance of a star from the earth is 8.33 light minutes. What do you mean by this statement? So we have to tell the meaning of this statement, and then we have to express this distance in terms of meter. So first of all, what does this statement mean? The statement means that light will take 8.33 minutes to travel from that star to the earth. So this is the meaning of it. So let us write that this first. It means light takes 8.33 minutes to travel from the star to the earth. This is what it means. Now it says express this distance in terms of meter. So for that I should need to know the conversion of light minutes into meter. So we have this 1 light minute is equals to 1.8 into 10 to the power 10 meter. So 8.33 light minute will be equals to 1.8 into 10 to the power 10 will be multiplied with 8.33. So let us multiply. So I am just considering this one as 18 and this as 833. So 18 3s is 54, 5 carry, again 18 3s is 54 and 5 is 59, 5 carry. 18 into 8 is 144 and 5 is 149. After decimal 1 place and here 2 places, so 3 places into 10 to the power 10 meter. But because we are writing in scientific notation, decimal should be between 1 and 4. So I have to make it 1 place backward, means the power will increase here by 1. So I will write it as 1.499 into 10 to the power, this is increased by 1, 11. So let us round it off, 1.5 into 10 to the power 11 meter. So this is the distance of 8.3 light minutes converted into meter. With this we come to the end of this first part of the numerical. We will not move to the second part of the numerical, which is based on vernier caliper and screw gauge. So now we begin with the second part numerical, okay, which is based on measurements taken by a vernier caliper and a screw gauge. So you must have gone through the theory of it. So knowing the formula is very, very important to work out the numericals based on this. So let us go through all the formulas. I have written them, I will explain them, and you kindly take a note of all these formulas. So we begin with, first of all, least count. Least count we will be denoting in short as L dot C always. It is the smallest measurement that can be taken accurately with the instrument. Any instrument which you have, whatever is the smallest measurement you can take accurately with that, that becomes the least count. So for example, if you have a meter scale, you can take 1 millimeter accurately with it, or the scale which you use for your geometry part, you can measure 1 millimeter accurately with it. So the least count of it becomes 1 millimeter. Then we come to least count of a vernier caliper. It will be the value of one main scale division, whatever is the value of one main scale division, minus the value of one vernier scale division. This is the first formula whereby we can find the least count. But then if you are making use of this formula, you will have to know what is the value of one vernier scale division. Another formula is a very useful and a short way of finding the least count of a vernier caliper, that is the value of one main scale division, and you divide that with the number of divisions in the vernier scale. So I have written total number of VSD, means vernier scale division. Then once we have taken the least count, now if we are measuring the length of anything, so observed reading will be main scale reading. So you have to know the main scale reading. Main scale reading is always the value which has been crossed by the 0 of the Vernier scale. So in the main scale, a value will be crossed by the 0 of the Vernier scale. That is your main scale reading. And then comes the Vernier scale reading. This Vernier scale reading is always that particular marking of the Vernier scale which will match exactly with one of the division of the main scale. So whichever one is coinciding of the Vernier scale, that will become your Vernier scale reading, and that needs to be multiplied with the least count which you will get in this case. Once you have got the observed reading, the correct reading will be the observed reading which you get from here minus the 0 error. And when you take the 0 error, you have to take it with the sign. If it is a positive 0 error, you need to take the plus sign and subtract. And if it is a negative 0 error, then also a minus sign because of the negative 0 error, and this minus ultimately will make it positive. Then that completes about everything regarding the Vernier scale, okay, or to say the Vernier caliper. Now we come to a screw gauge. So when we have a screw gauge, the pitch is the important thing. It is the distance moved in one complete rotation. So if you are making a screw making use of a screw gauge, you will have to rotate the screw complete one round. So when you rotate it, that will be moving in the main scale a particular distance. That distance which it moves in the main scale due to one complete rotation of the screw, that is called as the pitch. So remember, it will always be the distance for one complete rotation. Once you know the pitch, least count is calculated of screw gauge. Pitch divided by the number of circular scale division. It has a circular scale. So whatever is the number of the circular scale division, with that it has to be divided. Then observed reading will be the main scale reading. Main scale reading is what here? Okay, when you look at the circular scale would have crossed a particular reading of the main scale. That particular reading becomes your main scale reading. Then we come to the circular scale reading. Circular scale reading is the reading from the circular scale which will match or coincide exactly with the baseline given on the main scale. So that matching value will become your CSR, and multiplying with the least count which you will get. Okay, so that will give you the observed reading. Then the correct reading will be observed reading minus the 0 error, again with the sign. Same thing to be done what you are doing in Vernier caliper. Now one thing I would like to tell you here regarding the 0 error. Now when we have a positive 0 error and think the coinciding value is 2, second division is coinciding, then we simply take it as 2 as the 0 error. Okay, so remember that 2 with the 0 error, and then you multiply with the least count to get the 0 error value. Okay, now if you are getting a negative 0 error and think that the matching point is with the 7th division. If the matching is with the 7th division and the total number of division in the Vernier is 10, so you will have to do 10 minus 7. You get 3. That 3 you will multiply with the least count to get the value of the 0 error. Okay, so to get the value of the 0 error, the coinciding one has to be multiplied with the least count in case of positive 0 error, and in case of negative 0 error, you have to do the total number of division minus the coinciding part. What you get has to be multiplied with the least count to get the value of the 0 error. Same thing will happen in case of screw gauge also. Okay, the same thing has to be followed. So now we have seen the formulas. Make a note of all these formulas. We'll be moving on to the numericals of this part. So now we begin with the numericals. Let us see question number 1. It says the stopwatch has 10 divisions graduated between 0 and 5 second mark. It means from 0 second to 5 second there are 10 partitions, 10 divisions to it. What is the least count? So we know for any device we can get the least count by knowing the value of one division of it. 10 divisions of it has 0 from 0 to 5 second, means 10 division represents 5 seconds. So we will have to find for one division. So let us take a look at the solution. number 1. So we will write here least count equals to value of 1 division. So we get to see here that there are 10 divisions showing 5 seconds. So 5 divided by 10. So it comes to 0.5 second is the least count of it. So thereby we finishes the first numerical. Now let us take a look at the second one. It says a vernier has 10 divisions and they are equal to 9 divisions of the main scale in length. We always know that whatever is the number of vernier scale division, that has to be fitted in one less division of the main scale. So that is why it is fitted in 9 division of the main scale. If the main scale is calibrated in millimeter, now main scale is calibrated in millimeter means that the value of one main scale division is 1 millimeter and we are asked to find the least count. So we will apply the formula of least count. Number 2, least count equals to value of one main scale division, that is MSD, divided by number of vernier scale division. So we know value of one main scale division is given to you calibrated in millimeter. So it is 1 millimeter. And the number of vernier scale division is given to you 10. So that comes as 10. So it is 0.1 millimeter, and we can write it in centimeter by dividing with 10. So it will move one place backward, 0.01 centimeter. So that completes the second numerical. It is a direct to the formula numerical. Now let us take a look at the third one. Third one says a microscope is provided with a main scale graduated with 20 divisions in 1 centimeter. Means that length of 1 centimeter is divided into 20 parts, 20 divisions. And a vernier scale with 50 divisions on it. So vernier scale is having 50 divisions on it of length same as that of 49 divisions. So 50 divisions of vernier so will be fitted in one less division, that is 49 division of the main scale, and we need to find the least count of the microscope. So first of all, our task is to know what is the value of one main scale division. 20 main scale division is fitted in 1 centimeter. So I will try to find first of all value of one main scale division, that will be 1 centimeter divided by 20. So 1 by 20 centimeter. I am leaving it as 1 by 20 centimeter. I don't want to bring that in decimal. Then we know that number of division of the vernier is 50. So again using this same formula, least count equals to value of one main scale division divided by number of vernier scale division. So value of one main scale division we have got 1 by 20, and the number of vernier scale division is given to you 50. So it will come in the denominator. So that comes as 1 by 1000. This will be coming in centimeter because one value of one main scale division is in centimeter. 1 by 1000 will give you 0.001 centimeter. So if you compare the least count of the second numerical and the third numerical, this is a smaller value. So we say that this particular device is more sensitive compared to the second numerical which was there. It means this device will be able to measure it more accurately as compared to the second one. So I hope you all have understood the direct use of formula in finding the least count. So we now come to numerical number 4. Let us see what the question says. A boy uses a vernier caliper to measure the thickness of his pencil. So what is being measured is told he measures it to be 1.4 millimeter. If the zero error of the vernier caliper is plus 0.02 centimeter, what is the correct thickness of the pencil? So we are given the observed reading. We are given the zero error. We have to calculate the correct reading here. Okay, the correct thickness. So Let us look into the solution. So first of all, what I am doing is, let us write that zero error which is there, and that zero error is given as plus 0.02 centimeter. Now because this measurement is given in millimeter, so I am going to convert this into millimeter, and to convert centimeter into millimeter you need to multiply with 10. So if I multiply this with 10, it will become 0.2 millimeter, and the plus sign will be there because it's a positive zero error. So I will find the correct thickness. Correct thickness will be equal to observed thickness minus the zero error, and we will be writing the zero error with the sign. Okay, so observed reading for us is 1.4 millimeter minus, and the zero error is in plus, so I will write the sign plus, and 0.2 mm. Okay, so 1.4 minus plus is minus 0.2, so that will give me 1.2 mm. So this is not the correct thickness. So we are done with number 4. Let us take a look at number 5, what the numerical says. A vernier caliper has its main scale graduated in millimeter, so it means the value of one main scale division is 1 millimeter, and 10 division on its vernier scale are equal in length with 9 mm. So what we require is the number of division of the vernier scale, which is 10. When the two jaws are in contact, the zero of the vernier is ahead of the zero of the main scale. So zero of the vernier is ahead of the zero of the main scale means you should be clear it is a positive zero error. And then it is told third division of the vernier scale coincides. So the third one is coinciding with the main scale division. Find the least count and the zero error of the vernier caliper. So finding the least count, we have done it in a previous numerical, but let us see it again here. So the first one we are doing here. So least count will be value of one main scale division divided by number of vernier scale division, that is VSD. So that is 1 millimeter is our value of one main scale division, and the number of division of the vernier is 10. So we get it as 0.1 millimeter. So this is our least count, and in centimeter if you go to write 0.01 centimeter. Now the second part is asking you to find the zero error. So I had already explained you that because the jaws are contact, zero of the vernier scale is ahead of the zero of the main scale, so it is a positive zero error. So I am going to write that positive sign. Third one is matching. So because it is positive and the third one is matching, we need not subtract anything. Now we multiply it with the least count, which we had got it as 0.01 in centimeter. So this becomes plus 0.03 centimeter is your least count. Number 6, it says the main scale of a vernier caliper is calibrated in millimeter. So this information is that value of one main scale division is 1 millimeter, and 19 division of the main scale are equal in length to 20 divisions of the vernier scale. So what we need is number of vernier scale division is 20. Now in measuring the diameter of a cylinder, so now a cylinder diameter has been measured by this instrument. The main scale reads 35 divisions. So the main scale reading is 35 division. Each division is 1 millimeter. So we will get it as 35 millimeter is the main scale reading. And the fourth division of the vernier scale coincides. It means 4 is the vernier scale reading. Okay, with the main scale division, find the least count and the radius of the cylinder. So diameter we will get. To find the radius, we will have to divide it by 2. Okay, so first of all, let us go to find the least count. Value of one main scale division divided by number of vernier scale division. So this is 1 millimeter divided by 20. So 1 divided by 20, if I multiply both numerator and denominator with 5, I will get 5 by 100, which will make it 0.05 mm. Okay, so this is in millimeter. The least count is 0.05 mm. Now we will go to find the diameter. So I will write here diameter is equals to MSR, that is main scale reading, plus the Vernier scale reading into the least count. So main scale reading, it is clearly told here. Take a look here that the main scale reads 35 divisions. So one division is 1 millimeter. So 35 mm. VSR, fourth one is matching. This is the fourth one matching. So 4 into 0.05. That is also in millimeter. This is also is in millimeter. So this is 35 plus 4 5s is 20. So it means it will give me 0.2 mm. So I get finally this one as 35.2 millimeter. Okay, which in centimeter will become 3.52 centimeter, that is by dividing it with 10. So this is the diameter we are getting. So now radius you will get with 3.52 divided by 2. So 2 ones are 2, decimal 2 sevens are 14, and then 2 6 are 12. So this is your final answer with the radius coming as 1.76 centimeter. I hope you have understood this process of using MSR plus VSR into least count to get the length of anything required. So now let us see, take a look at number 7 numerical. It says in a vernier caliper, there are 10 divisions on the vernier scale, and 1 centimeter on the main scale is divided into 10 parts. So 1 centimeter into 10 parts, we will have to know the value of 1 division of the main scale by dividing 1 centimeter with 10. Okay. While measuring the length, the zero of the vernier lies just ahead of 1.8 centimeter mark. So remember, this is the value given to you. 1.8 centimeter is your main scale reading, because it is told that the zero of the vernier just lies ahead of 1.8 centimeter mark. And the fourth division of the vernier scale coincides with the main scale division. So that gives you the vernier scale reading as 4. You have to find the length, and then if the zero error of the vernier caliper is minus 0.02 centimeter, what is the correct length we have to find. So let us proceed to solve it. So first of all, we need to find the value of one main scale division. So value of 1 MSD. So see what is being told here, that 1 centimeter has 10 parts. So one part will be 1 by 10, that is equals to 0.1 centimeter. Okay. So now we know that the value of one main scale division is 0.1 centimeter. Now we will go to find the least count. Value of 1 MSD divided by number of vernier scale division. So this one we have got as 0.1, and the number of vernier scale division you can see was mentioned here as 10. So by 10, so I get 0.01 centimeter. Now we can go to find the A part, the length of it. So we will write here main scale reading plus vernier scale reading into the least count. So main scale reading is this one already told in 1.8 centimeter, plus your vernier scale reading is the fourth division matching. So 4, least count we have got it as 0.01. So 1.8 plus multiply it 0.04. So you get 1.84 centimeter as the length of it. But then B part is informing us that there is a zero error of minus 0.02 centimeter. So I will get now in the B part, the correct length will be equal to what we have got, this length 1.84 minus the zero error with the sign. Okay. So minus 0.02. So that you can see is 1.84. Minus minus is plus 0.02. So you get it as 1.86 centimeter. So this completes this numerical. Now we come to the numerical number 8. Now these numerical where the diagram is given are very important, okay, because board has mentioned that this is a new addition to the numerical part of this chapter. Okay, so let us take a look. It says Vernier scale readings are shown in the figures. Okay, so this figure that are telling Vernier scale reading is shown. Okay, given the actual reading provided. Okay, and in the A part, the instrument has a zero error of plus 0.02 centimeter. So we have to find what the length it is. The actual reading is what. So we have to correct that zero error, and zero error is given in value to us. So our main thing, first of all, we will go to find the least count for both of them. Both of them have the same type of main scale and the Vernier scale. So first I will go to find the least count. Value of one main scale division divided by number of Vernier scale division. So you can see here, this is your value of one main scale division, which is 1 millimeter, divided by, you can see the number of Vernier scale division 0 to 10. So there are 10 of them. So that gives me 0.1 millimeter, which I can write it as 0.01 centimeter. So I know the least count. Now let us take a look at the A part. So first of all, I should know the main scale reading. So I am first mentioning here the main scale reading. Now look at the 0 of the Vernier scale. This is the 0 of the Vernier scale. It has crossed this particular value, which is 1 centimeter. So I am writing here 1 centimeter. Then I will look into the Vernier scale reading. So in Vernier scale reading, you have to see which marking of the Vernier scale is exactly coinciding with the marking of the main scale. So if you take a look at them properly, take a look here, this one is exactly matching, and that is the 6th one. So I will write here Vernier scale reading as 6. No unit there, just that division has to be written, okay, and the division of the Vernier scale. So now I know them, so I can go to find the length which is there, okay. So length MSR plus VSR into the least count. So MSR I came to know as 1 centimeter, VSR is 6, because this is in centimeter, least count I will write with the 1 in centimeter. So 1 plus 0.1, 0.01 into 6 will give me 0.06. Okay, so I get here 1.06 centimeter. But then we have a zero error there. Okay, so actual reading they are asking. So actual reading, this is the reading I had got, minus the zero error. So zero error is given to us in plus 0.02 centimeter. So 1.06 minus plus is minus 0.02, 1.04 centimeter is the answer for this. Okay, so first part, A part has been done. We will take a look now into the B part. So in the B part, again I need to know MSR, okay, and I will also require VSR. So let us take a look. Look at that 0 of the Vernier scale. It has crossed this one, so that is 1 centimeter. Now which one is matching? Take a proper look and see. You will find, see, this one is matching exactly. So that is in the Vernier, that is at the 4th place. So 4 becomes the Vernier scale reading. Okay, so we will go to find the length now by the same formula. Okay, so 1 centimeter MSR plus the 4th one is matching 4 into the least count 0.01. So you will get 1 plus 0.04. So that gives you 1.04 centimeter. Then we have a zero error here of minus 0.03. Okay, so we will write here actual reading. So we had got as 1.04 minus and then the negative 1, which is minus 0.03 is the zero error. So 1.04 minus minus is plus 0.03. So that will give me 1.07 centimeter as the answer. So I hope you have learned from this how to take the main scale reading and the Vernier scale reading when the figure is given. So now we move on to question number 9, okay, which is again a diagram based numerical. So take a look. While measuring the length of a rod with a vernier caliper, figure 1.14 below shows the position of its scales. Okay, means how the vernier and the main scale are at this position. We are asked to find the length of the rod. So first of all, our task is to find the least count. We need to know the least count. So we go with the same formula. Least count equals to value of one main scale division divided by number of vernier scale division. Now what is the value of one main scale division? See, it is told here centimeter, and between any 2 centimeter like 5 to 6 you have 10 divisions. So each division becomes 1 millimeter. So we write here 1 millimeter and then divided by 10. So that gives us 0.1 millimeter, or to say 0.01 centimeter. So now we know our least count, which is a very important part. Now the next important part from this is to take a look at the main scale reading and the vernier scale reading. Okay, so take a look here. This is 3 and this 0 of the vernier has crossed this value, which is the third one. So our main scale reading becomes 3.3 centimeter. So our main scale reading we have got. Next we will require the vernier scale reading. So you need to see which one is coinciding here. So let us see which one is coinciding properly. So exactly this one is coinciding. And which is that one? The fifth one, you can see a longer line. The sixth one is coinciding. So your vernier scale reading is 6. Okay. So now we can go to find the length of the rod. Length is equals to MSR plus VSR into the least count. So MSR we had got it as 3.3 plus VSR was 6 and the least count in centimeter is 0.01. So this is 3.3 plus 0.06. So we get 3.36 centimeter. So this gives the length of this rod and this numerical is done. Let's move on to the 10th one. Now numerical, this is on the screw gauge. So it says the pitch of a screw gauge is 0.5 mm, it is told. Okay, and the head or scale is divided into 100 parts. Head scale is the same as the circular scale, that is having 100 parts. So number of circular scale division is 100. What is the least count of the screw gauge? So we write here least count. Okay, screw gauge written in short. Okay, pitch divided by number of CSD, that is circular scale division. So pitch is given to us here 0.5 mm and number of division here is given as 100. So divided by 100. So 2 places decimal will move, 0.005 mm, and if I want to bring in centimeter, 0.0005 centimeter, that is by dividing with 10 we get it in centimeter. So we have got the 10th numerical also done. Now we move to question number 11, which is again based on screw gauge. It says the thimble of a screw has 50 divisions. Thimble has 50 division means the number of circular division is 50. The spindle advances 1 millimeter when the screw is turned through 2 revolutions. So if there are 2 rounds taken, it is moving by 1 millimeter. This is the information. And what is the pitch of the screw? Remember, the pitch of the screw is the distance it will move in one revolution. Okay, and then we have to find the least count of the screw gauge. So we proceed here. So first of all, we will write here pitch is equal to, we have there, it advances by 1 millimeter in 2 revolutions. So in 1 revolution it will be 1 by 2, that is 0.5 millimeter. So this will be our least count, will be our pitch, 0.5 millimeter. If you want to write it in centimeter, 0.05 centimeter. Okay, now that is the first answer you have got. Now the second one says, what is the least count of the screw gauge? So least count is equals to pitch divided by number of CSD. CSD means circular scale division. So you had here 0 point, if I am writing in centimeter, and then this one is 50 divisions are there. Okay, so it will make the decimal move one more place back. 0.005 divided by 5 will give you 0.001 centimeter. So this is your answer for the second part. Okay, we will move on to the 12th one here itself. So 12th one says the pitch of a screw gauge is 1 millimeter. Pitch is given and its circular scale has 100 divisions. Okay, in the measurement of a diameter of the wire, a diameter of a wire is being measured. The main scale reads 2 mm. So main scale reading is given as 2 millimeter, and 45th mark of the circular scale coincides with the baseline. So your circular scale reading becomes 45. You are asked to find the least count and then the diameter of the wire. So first of all, the pitch of the screw gauge is given to us 1 millimeter. We don't have to find the pitch. So least count is equals to pitch by number of CSD, circular scale division. So 1 millimeter it is in, divided by 100. So 0.01 millimeter. If I want to change in centimeter, 0.001 centimeter. Okay, so we know the least count. That is your first answer. So first answer. Now the second part is to know the diameter of the wire. So first of all, we will write what all reading we know. We know this as the main scale reading. So MSR is equals to 2 millimeter, which in centimeter is 0.2 centimeter. That you always get it by dividing with 10. And then the circular scale reading is 45. So now I can get the diameter, main scale reading plus the circular scale reading into the least count. So main scale reading we had got it as 0.2 plus circular scale reading was 45 into the least count we had got it here as 0.001. So 0.2 plus, if I multiply with 45 ones as 45, so 0.045, you add it, you get 0.245 centimeter. So you have come to know the diameter of the wire also. So let's begin this number 13 numerical. When a screw gauge of least count 0.01 millimeter, so the least count is given to you directly, that makes your sums easier. Used to measure the diameter of a wire diameter has been measured. The reading on the sleeve is found to be 1 millimeter, means that is your main scale reading. And the reading on the thimble is found to be 27 division, that is your circular scale reading. You are asked to find the diameter of the wire in centimeter, and if the zero error is plus 0.005 centimeter, you have to find the correct diameter. Okay, so let us write the least count first of all. That is given to you as 0.01 millimeter. Because measurements are asked in centimeter, So I will write here 0.001 centimeter as the least count. Okay, the main scale reading is given to me 1 millimeter. So that will become 0.1 centimeter. Okay, so now then I will go to find the diameter. MSR plus CSR into the least count. So MSR is 0.1. CSR, you can see here it is told as 27. So 27 plus the least count 0.001. So 0.1 plus, if I multiply with 27, you will get 0.027. So you get it as 0.127 centimeter as the diameter. But then in the second part, it is told that it is having a zero error of plus 0.005. So now we go to find the correct diameter. So correct diameter will be what we got here as the observed diameter minus the zero error with the sign, that is plus 0.005. So 0.127 minus plus is minus 0.005. So subtract it, you get it as 0.122 centimeter. This is your answer. Okay, so it was a very direct numerical where most of the informations were given. Just put it in the formula and get it done. Let us come to see this 14 numerical. A screw gauge has 50 divisions. So number of divisions in the circular scale is 50, and its screw moves by 1 millimeter on turning it by 2 rotations. So distance moved 1 millimeter is in 2 rotations, not 1 rotation. When the flat end of the screw is in contact with the stud, the zero of the circular scale lies below the baseline. So remember, zero of the circular scale is lying below the baseline. It means it will have a positive zero error. And the fourth division of the circular scale is in line with the baseline. So the fourth one is matching there and with a positive zero error. It is asked to find the pitch, the least count, and the zero error of the screw gauge. So we will see it one by one. So first of all, they have asked us to find the pitch. So pitch is the distance moved in one rotation. It is in 2 rotations, 1 millimeter. So 1 by 2, which is 0.5 mm, or to say 0.05 centimeter. I always go to write in millimeter and centimeter both, because as it will be required further, we can get whichever one is required. Okay. So now we have got the pitch, the first one. Now in the second one, the least count. So you must be knowing the least count formula for a screw gauge by now. Pitch divided by the number of circular scale division. So pitch, we have got it there. I am using 0.05 centimeter one. Number of circular scale division is given to us here as 50. So by 50. So if I divide with 5 first, it will give me 0.01, and then with this 0 coming there, 0.001 centimeter becomes your least count. Okay. Now the third part is the zero error. So zero error, the matching line is given to you here, fourth one. So that is why 4 multiplied with the least count, that is 0.001 centimeter. So 0.004 centimeter, and this was a positive zero error. So write a positive sign, and this finishes this sum. Coming to numerical number 15, another important numerical because it is diagram based, and this is the diagram based numerical on in a screw gauge. So it says 2 micrometers are shown in figures. In this, there's the one figure coming. In the next one, I will take the other figure. Given below, give the actual reading shown provided. We have to tell what is the actual reading here. So, and the provided another information is least count is already given as 0.001 centimeter, and the zero error is plus 0.05 millimeter. You have to be very careful in this about the units. because at one place in centimeter, other place in millimeter. We will try to work out the entire thing keeping it in centimeter. Now comes the main part here, the main scale reading. This is mark given here as 0. So this is 1 millimeter, this is 2 millimeter. You can't see that 3 millimeter part. So this becomes your main scale reading. So I will write here main scale reading as 2 millimeter, which will be 0.2 centimeter. Okay. Now then you take a look over here. Now you take a look over here, which value of the circular scale is matching with the baseline. This is 15, then 20, then this is 25, so this is 21. So your circular scale reading is 21. Okay, so now we can come to know what the reading is exactly. Okay, so reading MSR plus CSR into the least count. Okay, so we have got MSR as a main scale reading as 0.2. Here we have got circular scale reading as 21, and the least count is given to us over here as 0.001 centimeter. So this is 0.2 plus 0.021. Everything is in centimeter, so 0.221 centimeter. So this we have got the reading, but then zero error is given, so the correct reading will be 0.221 minus the zero error, okay, in the sign, with the sign. So it is 0.005 centimeter, okay, because I have, this is in millimeter, I've taken in centimeter, so you can see I've shifted decimal one place back. So that is 0.221 plus minus is minus 0.005. So 1 and 5, so 11 minus 5 is 6. This will change to 1 minus 0 is 1. This is remaining as 2. So this is your answer. Okay, so how to make use of the pick which is given to get the information about MSR and VSR. If that is clear, these numericals are absolutely very easy. So now this is that second figure of numerical number 15. So if this is 15B, information given over here for this part is that the least count is 0.001 centimeter, zero error is minus 0.021 centimeter, and this is the figure given. So from this figure we need to know the MSR and the CSR. So let us work it out on the MSR word first. So I am writing here main scale reading. Let us take a look. This is in millimeter given. So if you take a look, this is a little bit longer line than this. So this is the fifth one and this is your sixth one. So this is your sixth one. So this becomes 6 millimeter, which is 0.6 centimeter. So I know now the main scale reading is known to us. Now let us come to the circular scale reading. So this is the circular scale reading part. Now this is 40. So the next one only is there. So our circular scale reading is 41. Okay. So now we can go to find the reading. MSR plus CSR into least count. So MSR is 0.6, CSR is 41 multiplied with the least count, which is given here as 0.001 in centimeter. Everything is in centimeter. So this I multiply, you will get it as 0.041. So this gives you 0.641 centimeter. So now you know the reading of it, but then there is a zero error that has to be rectified. So correct reading is equals to the reading which we got here, 0.641 minus the zero error with the minus sign. So minus 0.021, it is in centimeter. So 0.641 minus is plus 0.021. So we need to add here 1 plus 1 is 2, 4 and 2 is 6, and then 6. So we get here, this is the correct reading for this particular diagram. Now to question number 16, another sum based on diagram. So take a proper look at the diagram. First of all, let us go through the question. In figure 1.15, this is the main scale reading given to you. This is the circular scale reading. Okay. The reading obtained while measuring the diameter of a wire with a screw gauge. So diameter is being measured of a wire, and the screw gauge setup comes like this. The screw advances by one division on the main scale when the circular head is rotated once. So circular head is rotated once, it moves by one division. One division value you can see here is 1 millimeter. So the pitch will become 1 millimeter. Okay. Find the pitch of the screw gauge, the least count of the screw gauge, and the diameter of the wire. Let us study this figure first. So see, this value has been crossed. So that is 1, 2, 3, 4. 4 millimeter becomes the main scale reading. This is 40. Then a longer line is there, becomes 45. So 46, 47 is your circular scale reading. And now we have to work it out with this. So going by what is asked first, pitch. So about pitch, what is told that the screw advances by one division on the main scale. It means while checking it, if you rotate it once, it goes from here till here. So that becomes 1 millimeter. So this is the pitch of the screw. Okay. Now the second part is asked the least count. So least count, you know, is the pitch divided by the number of circular scale division. Now you will have to make out the number of circular scale division here. 40 here, 0 here. And between 40 to 0, you'll find there are 10 divisions. So it means the number of circular scale division is 50. So we write here 50. Okay. So when you go to divide it, if I multiply both with 2, it will become 2 by 100. So it will give me 0.02, that is millimeter, because the pitch was in millimeter. So this becomes the least count. The third one is to find the diameter. So MSR plus, I went down to write VSR. We are doing screw gauge, so that will be circular scale reading into the least count. Now MSR, as I told, 1, 2, 3, 4, that is in 4 millimeter, plus the CSR circular scale reading. This one is matching 40, 45, 46, 47. So 47 into the least count 0.02. So 4 plus, if you multiply with 2 here, 2 sevens are 14, 2 fours are 8, 9, 0.94. So you get it as 4.94 millimeter. I got everything till here in millimeter. If I want to bring in centimeter, shift the decimal one place back, 0.494 centimeter. Okay. So this finishes this another very important sum based on the diagram. So coming to the last numerical of this B part numerical of this first chapter, measurement and experimentation. So this is a very, very simple and a direct sum. It says a screw has got a pitch of 0.5 mm. What should be the number of divisions on the head, that is on the circular scale, so as to read correct up to 0.001 millimeter with its help. Now remember, this is your least count. Okay, because it is told correct up to this. So I will write here least count is equals to pitch by number of CSD, circular scale division. So least count is given to you 0.001, pitch is given to you 0.5, number of CSD you have to find. So now I will write number of CSD. So 0.5 will remain in the numerator. This will get divided 0.001. So if I shift the decimal this 3 places ahead, this will be remaining as 1. So here also 3 places ahead. will give you 500. It means the number of division on the circular scale should be 500. We have come to the end of this numerical based on vernier caliper and screw gauge involving least count. Okay, so we'll be doing also the numerical of the last part, which is mainly based on time period. Okay, and this one, if you have been liking this video, so please do remember to go back and subscribe to this channel. So now we begin with the numericals of the third part. So we come to this exercise 1C, which is based on time. So let us see the formulas first. We have got the first formula as frequency is equals to 1 by time period, and this can be used also as time period equals to 1 by f. And the second formula which we need here is the formula for finding the time period. T is equals to 2 pi root over L by G, where L is the effective length of the pendulum and G is the acceleration due to gravity. So only we will be requiring these two formula to do the numerical of this part. So let us see one by one all the numericals of this one. So we start with the first numerical, where the question goes like this: a simple pendulum completes 40 oscillations in 1 minute. So 40 oscillation is done in 1 minute. Okay, that is 60 seconds. You have to find its frequency and the time period. You remember, frequency is the number of oscillations completed in 1 second. We are given here 40 oscillation in 1 minute. That is 60 seconds. So the solution will go like this: number of oscillations in 60 seconds equals to 40. So then we will find number of oscillations in 1 second equals to 40 by 60. Zeros cancel. With 2 if you reduce, you will get 2 by 3, and 2 divided by 3 will keep on giving you 0.666 will keep on going. So we write it as 0.67. So this is the frequency we have got here. So we will write the unit as hertz. So we get the answer as 0.67 hertz, which is the frequency, and if you want we can write with the symbol 0.67 hertz is your answer. So this is your A answer. Now for the B part, it is asking the time period. So time period formula is 1 by f. Okay, and 1 by f, this was the frequency before calculating and getting, we were getting 2 by 3. So 2 by 3 means that 3 goes into the numerator. So 3 divided by 2 will give you 1.5. We are finding time period, so that gives us the unit as seconds, and this completes this first numerical. So let's see numerical number 2. It says the time period of a simple pendulum is 2 seconds. What is its frequency? Time period is given, you have to find the frequency, and what name is given to such a pendulum. You know that a pendulum with time period 2 seconds is called as a seconds pendulum. Okay, so let us write it. So we are given here t is equals to 2 seconds. They are asking the frequency. So I can write here f is equals to 1 by t. So that will give me 1 by 2, and 1 by 2 is 0.5. So frequency becomes 0.5 hertz, and it is a seconds pendulum. So that finishes a very simple and a easy numerical number 2. Now let us take a look at the third one. The third one goes like this: a seconds pendulum is taken to a place where acceleration due to gravity falls to 1/4. Means whatever is the acceleration due to gravity on the earth, it becomes 1/4 of that. How is the time period affected, if at all? So time period will surely change. So it is asking how it is affected at all. So then it is told give reason and what will be its new time period that is asked. So we will write here first of all seconds pendulum is there, so time period is 2 seconds. Then it is taken to a place where the acceleration due to gravity is 1/4. We know from this formula T is equals to 2 pi root over L by G that T is proportional to 1 by root G. So it is inversely proportional to the square root of G. So what is happening to G here? It is becoming 1/4. So G becoming 1/4 means 1/4 root will be 1 by 2, and because it is inversely proportional, so it will become twice. Okay, so we can write here that time period will increase and become double of what it is. What it is means how much it is, 2 seconds, so it will become double of that, that is 4 seconds. So we can write the answer 1 in this way. Another way we can solve and bring the value also, how it is becoming 4 seconds, doubling and becoming 4 seconds. So first of all, in that way, so I am just drawing a line to show you another method. T is equals to 2 pi root over L by G. We know this is the formula, and because it is a seconds pendulum, I can write T is 2 is equals to 2 pi root over L by G, and I call it as equation 1. Okay. Now the new time period which I have to find, where G is becoming 1/4, okay, of what it is. So I will get in the formula 2 pi root over L. Now G will be written as G by 4. So G here and 4 comes into the numerator. So now this I can write as 2 pi root over L by G, and this 4 goes outside the root. So square root of 4 is 2. Okay. Then I go to write here this part 2 pi root over L by G. From equation 1 you are having the value as 2. So for this part I will write 2 into 2, so that becomes 4 seconds. So you can see it was 2 seconds, it has got doubled to 4 seconds, and that also help us in finding what was asked, what will be its new time period. New time period will be 4 seconds. I hope this sum has been understood, and you can see it has been rated as a HOTS question, that is high order thinking skill. Okay, so this is a very, very important question. Now we will move on to the fourth sum. So let us now come to question number 4. The numerical is like this. Find the length of a seconds pendulum. So remember, seconds pendulum has a time period of 2 seconds at a place where G is 10 meter per second square to be taken, and it has been told to take pi as 3.14. So we go to write the formula. T is equals to 2 pi root over L by G. So T, because it is a seconds pendulum, so 2, and then pi they have asked us to take 3.14. Root over L we have to find, and G is told as 10. This number we bring it this side equals to root over L by 10. This 2 is cancelled. Root will come this side, so it will become square. So I will write 3.14 into 3.14 is equals to L by 10. So 10 will be coming here. L is equals to 10 by 3.14 into 3.14. Now there is a lengthy calculation. Okay, so you cannot escape from it. If it comes in any of the exam, you will have to do this calculation. But remember, we have been asked to tell the length of a seconds pendulum, which we remember it as very close to 1 meter. So you can remember when G is given as 10 meter, okay, then it comes to this value will come as 1.014, okay, 1.014 meter it will come up to 3 places of decimal. And if it is given as 9.8, okay, it will come very close to 99.89, okay, centimeter there. Okay, so this is in meter. If I am telling there as 99.89 centimeter, it will come. So if you remember this value, you can simply directly write it and escape from this calculation. So now we move on to numerical number 5. So let us see numerical number 5, which is a very important type of numerical. Compare the time periods of two pendulums of length 1 meter and 9 meter. First, this compare. Remember, whenever in physics it is asked to compare, you will give your answer in terms of ratios, not in terms of that this many times like this you will not be telling. It will always be in ratio. So we are given the length of two pendulum. We have to find the ratio of their time periods. So we go to do the sum like this. I write it as T1 by T2. In the numerator, it is 2 pi root over L1 by G, and then denominator L2 by G. Because the two pendulums lengths are different, I have written them in terms of L1 and L2, but G is not different. So that is why written as G. Now we can cancel this 2 pi and this G, and so I will get now T1 by T2 is equals to root of L1 by L2. Now we are given there the value of this one as 1 and 9. So 1 and 9 gives you 1 by 3. So finally we will put the answer as T1 is to T2 is equals to 1 is to 3. So the comparison is done, answer written in the ratio format. So now let us come to take a look at question number 6, which says a pendulum completes 2 oscillations in 5 seconds. So 2 oscillations is done in 5 seconds. What is its time period? Remember, the time taken for one oscillation is called as the time period, which you can easily find. Then it is told if G, with the B part, if G is 9.8 meter per second square, find its length. So we have to find the length of the pendulum the way we had done in the fourth sum. So let us first of all find the time period. So time period will be for 2 oscillations. It is 5 seconds. So time period will be 5 divided by 2. So you get it as 2.5 seconds. This is the time period. Now B part, this is your A part. Now in the B part, you are asked to find its length. So we make use of this formula. So here we will be writing 2.5, 2 into 3.14, root over length we have to find, and G is told as 9.8. So this number will come here, 2.5 divided by 2 into 3.14. Then it is root of L by 9.8. Now root will come here, it will get a squared of it. So I will write 2.5 into 2.5 divided by 2 into 2 and 3.14 into 3.14. This will be equals to L by 9.8. Then 9.8 also taken this side, you get it as equals to L. Now this is a very lengthy calculation. Calculate it at home and give me the answer in the comment. Okay. So this is the method of doing this sum wherever you will have to find the length of the pendulum. In most cases you will get the calculation length. So let us see now the next one, which we have to do is the 7th one. The question is the time periods of 2 pendulums at a place are in the ratio 2:1. So the ratio of the time period is given to us. What will be the ratio of their lengths? So we have to find the ratio of the lengths of the 2 pendulum. So again we go to write it like T1 by T2 is equals to 2 pi root over L1 by G, and then 2 pi root over L2 by G. Okay, so 2 pi will get cancelled, G will get cancelled. T1 by T2 is given to us as 2:1. So 2 by 1 is equals to root of L1 by L2. So the square will come here. It will become 4 by 1 L1 by L2. So we can go to write L1 is to L2 is equals to 4:1. So that finishes this question number 7. Let us take a look at the 8th one. It takes 0.2 seconds for the bob of a pendulum to move from mean position to one end. Okay, so this is the mean position and this is the one end. So only from here to here it is taking 0.2 seconds. What is the time period of the pendulum? So if I draw the other end also, so from here to here is 0.2, again 0.2, third 0.2 and fourth 0.2. So you can simply write here time period is equals to 0.2 into 4, which gives you 0.8 seconds. So a very easy sum being given at the end. Ninth one is another very easy sum which says how much time does the bob of a second's pendulum take to move from one extreme of its oscillation to the other extreme. It means they are asking for the time taken to go from here to here. The time period of a second's pendulum is 2 seconds going from here to here and coming back. So it is only asking you one part of it. So I will write time taken to go from one extreme to the other equals to second's pendulum has a time period of 2 seconds. So that divided by 2, so it will take 1 second. So with this, we have come to the end of all the numericals on the topic measurements and experimentation. Wait for the videos to come for the solving of the numericals on the chapter motion in one dimension. To get the videos of the coming up chapters, do remember to subscribe to the channel and put the notification button on. So the moment I post it, you will be able to get this video. Thanks for watching the video. Keep watching, keep sharing with your friends. Thank you.